All right, hey everyone. This is going to be a pretty brief video, just kind of explaining a little bit more about why we can make this interpretation when we have the log response. In the previous video, we just kind of wrote it out, but didn't really give a ton of reasoning behind it, partially because that reasoning is a little bit mathy. And like I think I mentioned before, this class doesn't have a math prereq at all, and so the prereq is just Stat 113, and so there's no calc prereq. But to kind of talk about why we can make this interpretation, you really only need like pre-calc knowledge, pretty much. I think I think that's actually it. So I'll say from the get-go that you could just stop watching this video right now if you're not interested. Um, we won't have time to, or you won't ever be quizzed or tested or anything on the material covered in this. This is just for people that might not completely be satisfied with the reasoning that we gave for this. All right, so I'm just going to turn this page over, and we want to make the argument that we can make this statement about a multiplicative change in terms of the median when we have our log response. And so what I'm going to do just to start is write out just a very general regression, fitted regression equation where we've log transformed our response, and then we just have general fitted intercept and fitted slope in our equation that involves one single explanatory variable. Okay, so what we could do is raise both sides by e to kind of cancel that out, to put everything on, or put the response back on the scale of its original units. And the question we want to know to start out with is, all right, well, what happens when x increases by 1? All right, so to start, I'm going to just make a note of the predicted value of y for this particular value of x. So I'm just going to denote it with a little x so that I can keep track in my mind. And now, if we increase x by 1, then our predicted value of y would be this. And so through some kind of algebra, we can modify this just distributing the beta hat 1 and then breaking up our little e parts. Since there's addition, we could break them up into separate parts and multiply them together. All right, and so from this point, it should actually be pretty easy to see that if we increase x by 1, we would be multiplying the previous fitted value of y hat by this e to the beta hat 1. So I'm just going to put those back together, make a note that, all right, back up here, that's exactly what that is. And so we have that our predicted value for y when x is x plus 1 is just our predicted value for y for the generic value of x times e to the beta hat 1, and that's exactly what we had on our previous page for that interpretation. The extra jump that I think you would need some sort of knowledge about functions for is, well, okay, that's all well and good. We have our predicted value is a multiplicative increase by e to the beta hat 1. But we also made a note that we could make this interpretation not just about a predicted value in general, but about the median brain weight. And we made a specific note that we would have to do this interpretation in terms of the median, not the average. And so the reason for that is, so we'll just write this down as a fact first, but so the mean of the log of the response is not going to be equal to the log of the mean. If you wanted to test this out in R, you could by just kind of finding the mean of a log transformation and then first taking the mean of some response and then taking the log, and you should find that those numbers are not equal unless you got really unlucky and they just happen to be equal for some crazy specific example. But you might also recall from your function knowledge that a log is a monotonic one-to-one transformation. And because of that, the median of the log of the response does actually equal the log of the median. Because of this equality, nothing gets kind of screwed up here when you do this back transformation in terms of the median, but it does get messed up in terms of the mean because of this inequality. And so this is the reason why we could still make this interpretation on the median, whereas we can't do it for the mean, is because the log is monotonic and one-to-one, so that means the median of the log is the same as the log of the median. So one last thing you could do to kind of ask yourself, well, why wouldn't the same logic work for other transformations? Like, why is this so specific to the log of the response? Why can't we do it for, say, the square root of the response? And so if you tried to do the same type of logic for the square root of the response, so I'll just do the symbol. And so you had your fitted equation. And then if you know you want to make the interpretation back on the original scale, what you would end up doing is squaring both sides. And then seeing what would happen if you increased x by 1. You'll quickly see if you attempt to do this, which I'm not necessarily recommending, is that squaring these terms quickly kind of makes this out of control. And there's a bunch of different terms with x squared. Some of them have beta hat naught, some of them beta hat ones, some of them just have x. And it's just not interpretable like it is up here where we had this kind of nice property that y hat kind of plugged in pretty nicely. Okay, so again, if you watched this video and kind of that didn't make sense, you could definitely feel free to ask me about it and I'm happy to chat. And if it didn't make sense and you're not interested in kind of learning a bit more about this, then definitely no worries. This is a step kind of above, and in fact is something that I wouldn't have actually talked about before the COVID times, but now since we're already used to watching videos, I think it's this is kind of an advantage of it, is that those of you that might be interested can kind of look at this extra explanation of why we can interpret when we have a log response. All right, so thanks for sticking with it, and definitely let me know if you have any questions about this.